Java has this feature for managing data that's local to a thread by this concept called thread local. All right, here's the motivation for this feature. So let's say you want to access a value or a variable in multiple places in a thread. Right, so you have your runnable, which has a run method, which calls another method, which calls another method, and so on. So let's say this is your use case. I have a process user data, which is my runnable, and I want this to execute in a thread. I'm passing a user ID to process user data, and my process user data takes this user ID, and then it calls a bunch of methods. It does something else, it does something else, and all these different things need to access the user ID that's passed in. So you need to access the user ID in multiple places in your thread. And now each time you're calling this, let's assume that a different user ID is passed. Every thread gets a different user ID, and then that thread has to process that user's data. So you have a bunch of options here. One is you can basically pass that variable around everywhere. You pass the user ID to all the methods which need to execute when that particular thread runs, which can be inconvenient, right? Or you can have like a class member variable, where you save it, and then every thread reads from it. So this option is inconvenient. Right, you are adding an extra variable to the method signature everywhere. And what if it's not just one data? What if it's like a bunch of different things? You need to pass all of that stuff everywhere in that thread. And this one is prone to synchronization issues. So what if you don't really care about a global class member, but instead you want something which is specific to a thread, right? Each thread needs to get its own data or its own variable. So the option that you would typically use in this kind of a context is to create a thread local variable. You can create a variable which is local to a specific thread, and it's not visible to anywhere else. So the visibility guarantee or the access scope guarantee for that variable or that data element is within a specific thread. This is how it works. So a thread local has per thread scope, and it is essentially global in the context of a thread instance. Any piece of code that runs in a particular thread has its own copy of that data element, and then any piece of code in that thread, when it tries to access it, gets only that. Okay, so it's kind of like the mechanism for getting and saving data is essentially the same, but each thread sees its own thread local variable and nothing else. Okay, so here's how you declare and define a thread local. Okay, so here is my thread local user ID. So let's say I decide and say, okay, I want user ID to be a thread local variable so that everything in a thread gets a common user ID. So I create a variable which is thread local of a generic type, right? So say I want to save an integer, I do thread local of integer. This can be any other object instance as well. So I create a new thread local. Now what the JVM does is every time a thread starts, it's only then that it creates a space for this user ID. So if I save something to thread local user ID for thread A, and I try to retrieve something from thread local user ID for thread B, they are not going to be the same thing. They're going to be individual, separate stuff, even though the code is essentially the same, right? So let's say I do something like this. I don't set a value directly. What I do is I use a method called set to set a value to this thread local, and I use a method called get to get the value from the thread local. You can almost think of it like a package where you put and retrieve things from, right? And the thread local class and the implementation does the right thing. So here, thread A, I do thread local user ID.set of this value. I'm setting a value to a thread local, and in that same thread, I do a get from the thread local. What I'm going to get back is the value that I've set. In a different thread, I set something else, and I do a .get. I'm going to get the value that I set in that thread, right? So it's individual and unique to a thread. So it's a generic class. It's almost like a wrapper. Like I said, you don't write to a variable directly because that wouldn't make sense. You do a .set to set a value to thread local, and you do a .get to get a value from a thread local. It's almost like a wrapper, and each thread sets and gets a different value. Right, so here is the Java doc for thread local, and based on the doc, it says the class provides thread local variables. These variables differ from the normal variables, normal counterparts in each thread that accesses one. Each one has its own. Instead here, you have an independently initialized copy of the variable, right? Thread local instances are typically private static fields and classes that wish to associate state with a thread. like a user ID or a transaction ID. You can typically make it as static fields so that you don't need to create a new instance every time. Instead, the thread local is responsible for creating separate spaces for data for different threads, right? So this is thread local.